Now, in spinor, what I shouldn't have erased, find a 95% confidence interval estimate of mu. We're going to apply that to the spinor. What does that mean in practice? We have a big population in the back of the book, or if you have it built into Excel, if you will. And that averages, we know it's 4.5, but make believe we didn't know it's 4.5. So we're going to take a sample of 5 numbers, and calculate the average, which we don't know yet because you haven't taken the 5 numbers. We're going to calculate the standard deviation, which again you don't know yet because you haven't done it. We do know that it should come out to pretty close to 4.5 and pretty close to 2.87, but we know that. The degree of freedom in this case will be 100 minus, be 5 minus 1, or 4. The degree of confidence is, for the spinor assignment number 27, I specifically asked for an 80% confidence interval, which is unusually low but useful for our purposes, which means the picture is going to be 1 minus 80 over 2. The middle part's going to consist of 80%. The middle part's going to consist of 80% of the area, which means this piece here is going to be 10%. So when it comes time to go to the back of the t-table, you're going to be looking up 10% area, and we'll find out what that number happens to be. But the formula is going to stay the same. That's what we're trying to demonstrate right now. And of course, the formula is going to have a few things in it that we can do right away. We know the n is going to be 5, square root of 5. The s will take a couple of minutes right now to figure out. The x bar we don't know yet. Let's do the t. The t is really the hard part of this thing. It's new. How do you get to t? So those who have a t-table, which I think I asked you to bring to class several times, including threatening to throw you out if you don't have it. Look up the t-table where you go down to row number 4 and column number 10%. Now what do you see there? I think you're going to see 1.5332. Is that the right answer? 1.5332. So that number will be placed here eventually. So all we have left to do, and by the way, after I get everybody's answer, hopefully at least 5 people, I'm going to put it on the same picture we had last time. Namely, we know the mu is 4.5. So this is a good educational example because we know the answer before we start. So well, let's see if, in fact, if 4 out of 5 or 80% of the class covers the mu. So when you give me your pairs of numbers, I'm going to put it onto this particular framework. This is a 5. This is a 6. This is a 7. This will be an 8. This will be a 4. This will be a 4.5, 3, 3.5, 2, 1.5, 1. Okay, down to 0, up to 9. All right, so let's go. So please do it. Take out, for either if you have a question, you can ask me to explicate it. But if you don't have a question, I'm going to turn off the tape right now in a second. And I'm going to tell you, you've got to pick 5 numbers. How do you get 5? Well, either you go to the back of the book, pick 5 numbers out of the random number table. Just pick 5 numbers, get the average. More complicated, calculate the standard deviation of those 5 numbers. If you already have the spinor assignment with you, some of you gave it to me and I haven't had a chance to mark it, but if you want to borrow, go back and take back your spinor assignment where you have many examples of 5 numbers, where you already have the average and you may have the do you have the standard deviation of 5 numbers? I don't think so. No. I don't think we did that yet. So you don't have it, so I take it back. But what you should not do is just make up 5 numbers, please. If you don't have a random number table, you can borrow from a couple of people that do have them. Just walk up, borrow 5 numbers. No charge, I hope. And take those 5 numbers, go bring them back to your desk, calculate the average, calculate the standard deviation, plug it into the formula, and about 5 minutes from now, we should have pairs of numbers popping out of that calculation. So I'll wait low. They were like lower than 2.8 average. And she also picked them very close together, so a standard deviation was much lower than 2.87. So, but that's going to happen on occasion. So that means that's exactly what the mathematics of the formula accounts for. It's saying that 80% of the time, if you do this process, which means 4 out of 5 times, you're going to come up with an interval that you can say, I'm pretty sure it's between here and here. So Adiz is also sure, again, assuming she didn't know the answer was 4.5, she would say, I'm 80% sure that the answer is between here and here. And it turns out she's wrong. I mean, it's like taking a bet. So this pretty much demonstrates the fact that what a confidence interval truly is. You have to really imagine it being repeated. Again, in real life, you don't repeat it. But if you would repeat it, you would get a pattern like this, which is very nicely demonstrated by the class's data.